Milky Way. It's the star cluster that we call home. Welcome to the Milky Way galaxy. The Milky Way is a galaxy or a giant cluster of stars which our planet, the Moon, the Sun, and the rest of the solar system belong to. Its name comes from the fact that the huge amount of stars at night appear like bands of milk in the night sky. Before we dive in, let's talk about galaxies first. A galaxy is a gravity-bound system that is comprised of stars, planets, gases, dust, and other interstellar debris. Actually, the word galaxy itself comes from the Greek term galaxias, which literally means milky. This is in reference to the milky appearance of the Milky Way galaxy. In Greek mythology, it is said that Zeus placed his infant son Hercules on the goddess Hera to be breastfed. The Milky Way is said to have been formed from some of the milk that was spilled in the process. Galaxies can be categorized according to size and according to shape. Sizes can range from dwarf with a few 100 million stars to giants, which has stars in the number of trillions. On the other hand, galaxies can also be classified into shape or morphology. Examples of which include spiral, elliptical, ring, lenticular, and irregular. Now let's zoom in a bit to the Milky Way galaxy. The Milky Way is a barred spiral galaxy, and it has a huge diameter, which is approximately between 100,000 to 180,000 light years. It is estimated that the Milky Way contains somewhere between 100 to 400 billion stars, with at least 100 billion planets. The solar system is located somewhere approximately 26,000 light years from the Milky Way's galactic center. The center of the Milky Way is marked by a high-intensity radio source, which astronomers call Sagittarius A. Some scientists suggest that Sagittarius A may be a supermassive black hole and is responsible for creating the strong gravitational pull, thus keeping the stars in the Milky Way together. The Milky Way and nearby galaxies form a local group, which is called the Virgo supercluster. On a clear night, we can see part of the Milky Way on Earth. It has a hazy white appearance, which can be viewed 30 degrees across the sky. On a side note, technically, all the stars visible on Earth is part of the Milky Way. On a clear night, however, the light from the Milky Way can be seen on Earth, but that's just a small part of it. That's because the Earth is so small compared to the size and mass of the Milky Way itself. Enceladus. It's one of the most studied moons this side of the solar system. Today, let's find out why as we talk about the moon named Enceladus. Enceladus is the 6th largest moon of Saturn. It has a diameter of approximately 500 kilometers or 310 miles. Enceladus itself is covered by fresh, clean ice. This makes it one of the most reflective objects in the solar system. It has a surface temperature of negative 198 degrees Celsius or negative 324 degrees Fahrenheit. Enceladus orbits around Saturn with a period of 1.4 Earth days. Enceladus was discovered by William Herschel. If the name sounds familiar, Well, you guessed it. William Herschel is the same person who discovered the planet Uranus, among others. Herschel used a 1.2 meter or 3.9 feet telescope, which was at the time considered as the largest in the world. Enceladus is named after Enceladus the giant from Greek mythology. Enceladus was the son of the goddess of the earth Gaia and the god of the sky Uranus. William Herschel decided to name his discovery after it at the insistence of his son John. And here's where it gets interesting. Scientists discovered something amazing when the Voyager spacecraft first took pictures of Enceladus in the 1980s. The pictures reveal that Enceladus has a clear icy surface. The icy surface on this moon gives it a very reflective appearance. You can think of it as a large space mirror. This feature is what makes Enceladus one of the brightest objects in our solar system. Further observations suggest that this moon may be composed of a rocky core, frozen ice water, and a frozen mantle. Additional examinations of the planet suggest cryovolcanic activity. This means that there may be active volcanoes underneath the icy surface of this moon. As these interior volcanoes erupt, small geysers appear as cracks on the icy surface of Enceladus. The Cassini spacecraft was able to take images of the geyser activity on the moon's surface during its close-up flybys of Enceladus from 2004 to 2015. Scientists think that the material ejected from these geysers form part of Saturn's rings called the E-ring. The volcanic activity and the presence of water in Enceladus leads many researchers to wonder if Enceladus can develop life, or at the very least, have the potential to be habitable by humans. If you think about it, Enceladus could potentially be a small Earth with its rocky core, volcanic activity, and icy oceans. For now, there have been some proposals to further explore Enceladus and perhaps even bring some samples from the moon back to the Earth for further study. And who knows, maybe humans will be visiting or even living in Enceladus in the future. Saturn, the sixth planet from the Sun, coming in with a diameter of 120,536 kilometers, or 74,897.6 miles, and a mass of 5.68 times 10 to the 26th power kilogram, or 1.253 times 10 to the 27th power pounds, equal to 95 Earths, with 62 moons and 30 rings, and an orbit period of 10,756 days, or 29.5 years. With a temperature of approximately -178 degrees Celsius or -288 degrees Fahrenheit. It's the planet with the awesome ring system and is the farthest planet seen by the naked eye. Welcome to Saturn. Saturn is the fifth brightest object in the sky. It can easily be seen without the aid of telescopes. Saturn takes its name from the Roman god Saturnus. The planet has been known by the ancient people from Babylon and the Far East. Saturn is mostly composed of hydrogen layers that get denser as it gets closer to the planet's core. The core is said to be made of a metallic composition with a hot inner core. Saturn is a gas giant and has different layers of gases. Its atmosphere is divided into different bands of clouds that are composed of ammonia ice, water ice, cold hydrogen, and sulfur ice. Among the other planets, Saturn has the most elaborate ring system. The rings are mostly composed of ice and dust debris. The rings stretch out to more than 120,000 kilometers, or 74,564.5 miles, but are only 20 meters or 65.6 feet thick. Saturn has many moons, and some of its larger moons have been observed to have oceans below its icy surface. To date, there have been 4 spacecrafts that have visited Saturn. These are Pioneer 11, Voyager 1, Voyager 2, and the Cassini-Huygens mission. Tides. Here's another example of interstellar bodies affecting each other. It's closer to Earth than you may think. So for today, let's talk about tides. Tides are the rise and fall of the water levels in the seas and oceans of the Earth. This rise and fall is caused by the Moon's gravitational force that it exerts on the Earth's waters. When the Moon is closer to Earth, its gravity exerts a pull on the Earth's surface. This gravity is less than the Earth. That's why the Earth does not get pulled in by the Moon. But it's enough to cause water in the seas and the oceans to rise. When the Moon's gravitational pull is at its highest, this results to what's called a high tide, a period where ocean levels are high. On the other hand, when the Moon's gravitational pull is at its lowest, this results into what is called the low tide, or the lowest water level of the tide. In case of a full moon or new moon, the sun also affects the level of the tides together with the moon. During these phases, the high tides are at its highest and the low tides are at its lowest. These type of tides are known as spring tides and are especially strong because of the combined gravitational pull of the sun and the moon. During the moon's quarter phases, however, the sun and the moon are at right angles to each other. This causes some of their respective gravitational pull to cancel out each other. This results to a weak type of tide called neap tides. Since the Earth, Moon, and Sun move in a consistent pattern, tides can be accurately predicted. The ancient peoples of Earth have studied this extensively and have accurately predicted tides for hundreds of years. This is especially helpful for people living near coastal areas to prepare for rising water levels. Tidal data also helps seafarers with navigation, especially in areas that are shallow and narrow. Engineers are also reliant on tidal patterns and data when designing structures over bodies of water, like bridges and docks. Tidal data also helps small-scale industrial and recreational fish-catching activities. Knowledge of tides helps improve the quality of catches as certain fish favor specific tidal conditions. Marine habitat restoration activities are also dependent on tidal activity. Tides also determine the flow of sea and ocean traffic, especially in active routes where many ships and vessels pass by. And finally, tidal data are also useful for sports and recreational activities in the oceans and seas. Eclipse. Here's another interesting phenomena in space that you can observe right here on Earth. Today, let's talk about eclipses. So what are eclipses? Well, eclipses are the name given to the phenomenon when a celestial body, like the sun, is obscured by another celestial body. This happens when a celestial object passes behind or in front of another object, thus obscuring the view and casting a shadow from the observer's viewpoint. The term eclipse actually comes from the Greek word eclipses, which translates to abandon or darken. Before people knew what eclipses were, they used to associate eclipses with disaster and bad omens. In some cultures, eclipses were thought to be caused by giant monsters swallowing the sun. The most common type of eclipse that can be observed in the Earth is the solar eclipse. The solar eclipse occurs when the moon passes in front of the sun, slightly covering it as observed from the vantage point of Earth. Another type of eclipse is the lunar eclipse. This happens when the Earth blocks the sun in reference to the moon's position. Lunar eclipses can only happen during the full moon, when the moon is at the far side of the Earth. Because of this, a lunar eclipse can only be seen on one hemisphere of the Earth. When eclipses occur, there are usually shadows cast by the blocking object to the blocked object. The region of the blocked object is divided into three parts. There's the umbra, the area where the object completely blocks the light source. Then there's the antumbra, the area where the object is completely in front of the light source but is too little to be able to cover the whole light source. And finally, there's the penumbra, or the region where the object is only partially blocking the light source. A total eclipse happens when an observer is inside the region of the umbra. On the other hand, when the observer is at the antumbra, the eclipse is called an annular eclipse. And lastly, the eclipse is called a partial eclipse when the observer is within the region of the penumbra. For lunar eclipses, only the umbra and the penumbra are visible. That's because of the size of the moon. From the moon's viewpoint, the Earth's apparent diameter is nearly 4 times that of the sun. Since ancient times, people have been keeping track of solar eclipses. The purpose of this is to serve as important markers or reference points with regard to solar events of the era. One of the earliest records for a solar eclipse comes from a Syrian tablet dated from 1223 BC. Another one can be found in an old Irish record from 3340 BC. Elsewhere, ancient Chinese astronomers have kept solar eclipse records for over 4,000 years. A look into the past. The telescopes that we have lets us look at objects light years away. When we look at objects in the sky, we're actually seeing it from a much earlier point in time. The effect is so that it is as if we are peeking into the past, much like how a hypothetical time machine does. But how? Well, consider this. Humans are able to see things because of the light that is reflected of our eyes. When light hits an object, it reflects back to our eyes, and our brain processes the image. This is how we can see. Now, this process of reflecting light happens at such a fast pace that we hardly ever notice it. But what if the light that we see needs to travel a far enough distance before it reaches our eyes and brains? Remember that light travels fast at a rate of 300,000 kilometers per second, or 186,282.397 miles per second. The nearest star to Earth, the Sun, is still 149.6 million kilometers, or 92.96 million miles away. Even at the speed of light, light from the Sun will take around 298.6 seconds before it can even reach Earth. Exactly the time it takes for us to see sunlight. Enter the light year. The light year is a measurement of distance that is equivalent to the distance that light can travel in a year, which is somewhere along 9 trillion kilometers. So if something is a light year away, it would also take the light from that object exactly 1 year before it can be seen. For example, the nearest star cluster to our own Milky Way galaxy is the Andromeda galaxy. Andromeda is around 2.5 million light-years away. Because it's 2.5 million light-years away from Earth, the Andromeda galaxy that we are observing is the Andromeda galaxy as it was 2.5 million years ago.